Catherine, you got a number for me yet?
12.
12? Okay. So we have lots of 10s, we have a 12, we have a 13, and we have a 20. I want you guys to be aware that it's okay if your numbers don't make sense and don't look similar, because this is just a rough idea of the ratio between how much acid and how much base we need, okay? So just to kind of get you guys mindful, is I'm going to be, let me backtrack. Okay. The titration assessment is going to be done in 4 parts, if you guys remember, and each part I'm going to assess separately instead of doing one big exam at the end, because I figured that's not fun for you guys. So we'll do part A, I'll do all the teaching, you guys will do all the practice, and then we'll assess it, and then we'll move on to part B. I'll do all the teaching for part B, we'll do the practice, we'll assess it, and move on to part C, etc., etc. Now, because we're doing it this way, it's really important that we color code which group is which, because you're going to have multiple practice and teaching assessments, and each one's going to be looking at a different solution. So the first color we're looking at is stuff that's printed on a yellow piece of paper. So the yellow piece of paper is all of the teaching examples, so for part A, B, C, and D. So you'll always have yellow paper if you're dealing with something that is an example that I'm giving you guys notes on. This example here, you are looking at lactic acid found in sour cream. So this is going to be the sour cream example. We're measuring lactic acid. In the practice one, I can't quite remember what you're doing. I think it's buttermilk, and I can't remember the acid for that one. I think it's probably lactic acid as well. And then the actual assessment, we're going to be looking at vinegar, and you're going to be testing for ethanoic acid. So that is the theme of what you're looking at. So I'll print teaching stuff on yellow. When you guys do a practice assessment, I'll put it on purple paper, so that way you can tell the difference of which set is for which set, because like I said, we're going to be doing A first, and then B, and then C, and then D. So I want you to be able to grab all of all of the teaching examples and be able to compare them against each other, because there's one big story. Does that make sense? All right. So first thing I want to talk about then is what is part A, so you guys can understand that, and then you guys will have a chance to practice that. So let's pull out so I'm going to have mine on white piece of paper, or do you guys want me to do it on yellow? Doesn't make a difference. Just on white's fine? Okay. So let me show you guys what the assessment's going to look like. I decided not to print out this first page for you guys because I figured having the marking schedule is going to be a more useful piece of paper on your yellow piece of paper. So just be mindful. I didn't print this out because I thought it wasn't as useful as the other piece of paper. So just so you guys are aware, you are looking at the quantitative analysis assessment. You are trying to figure out the presence of, carry out a practical investigation into a substance present in a consumer product using quantitative analysis. So quantitative analysis, we're talking about quantity. So we're trying to figure out the amount of something in a consumer product. So in this first example, we are looking at sour cream. In the practice example that you guys are going to be doing, you guys will be looking at buttermilk, and then the assessment you're looking at vinegar. So like I said, this is going to be assessed in 4 different parts. This is just the introduction. So some things to keep in mind: that you are going to be carrying out a procedure. You're going to be modifying it. You're going to calculate. You're going to check to see if you have accurate results, and you're going to write a conclusion. So this is just giving you an overview of all the different steps that you're doing. Yeah, so there's going to be 3 different versions.
What's the last?
The last one's vinegar. So the first one we're doing is going to be sour cream and looking at the ethanoic concentration in that. Second example is going to be buttermilk and looking at the ethanoic concentration, lactic acid concentration of that. And then the third one is going to be vinegar and figuring out the ethanoic acid concentration in the vinegar. Okay? This is just going to be an overview saying that you're going to have it in 4 different sections, and I'll show you each one as we go through it. So here's the first one. This I did print and put on your yellow piece of paper because it is useful to understand, so that way you know what you're trying to do. So background. Sour cream is a common ingredient in many foods. Lactic acid is added because it contains that sour taste that we want in many of our dishes. However, the lactic acid concentration in our sour cream can vary. Typically, you find the lactic acid concentration in your sour cream to be about 55%. However, in the process of purifying it, the lab technician says that it should be around 11%. So what our calculations are trying to prove in this assessment is that the lactic acid that the technician has prepared is at 11% of my solution. Are you guys okay with that so far? All right. So you are going to be carrying out an investigation to prove that it has been purified correctly and it is at 11%. So the procedure of this titration is going to be given to you, but we want to first see if you guys can write the procedure for it and then check it against it. So here's our chemical equation. So this here is our lactic acid. It is reacting with sodium hydroxide, which is our base. And with that, we have a neutralization reaction. When I have equal amounts of acid and base, it'll be neutralized, and that is that pale pink color that I'm trying to get. This is a 1-to-1 ratio. So whatever I figure out whatever amount of sodium hydroxide I use, that will then equal the amount of lactic acid that is present. So it's a 1-to-1 ratio here. So we need to do an experiment, though, to figure out how do we conduct it. So before we dive into titration, do you guys remember how I did the titration last week? And when I did it, I used 10 mils of the unpurified sour cream. And when I did that, I did a titration and it used 50 mils at least. And then I still kept doing it and it's still, I didn't bother doing it anymore because it would have caused more error. So what we discussed last week is I need to do something to fix this protocol because the protocol as is not going to work. I had two options, if you guys remember. I could either make the sodium hydroxide more concentrated or I could dilute down my acid. And we said that diluting down the acid would be the better option of the two because then I'm not using as much reagents. Are you okay with that so far? So what part A is trying to figure out is how much do I need to dilute my acid by in order to do my procedure correctly. Are we okay with that so far? All right. So I've been given some information. I've been given some ideas of what equipment I have, and I also have the solutions undiluted so I can see what the ratios are. So first step is I need to estimate how much sour cream I need, sorry, how much sodium hydroxide I need to neutralize my sour cream. I'm going to do this example for you guys, so use my numbers. So we have taken 1 mil of the sour cream, and in fact, I should start using the color codes for the assessment so you know what the Achieve, Merit, and Excellence are. So let's start doing that. All right, red is for the Achieved. So everybody needs to be able to do this in order to get the Achieved. So right now, I have 1 mil of the sour cream. I've added my indicator, and if you guys remember, I put 1 mil of the base in there already because I was trying to show you guys how to do this. So right now I have 1 mil of base. So we're going to go through and count just like you guys did. So that was 1, this is 2. Here's 3. 4. 5, 6, 7. Oh, staying? No, 7. 8. Oh, it's getting close. 9. It's gonna stay? Nope. 10. There you go. Now it's staying. All right. So I took 10 as well. That's good. It means a lot of people were close to mine. If you are not, it is okay because this is just a rough ratio. The good news about this assessment is you're going to be able to write it up, and even if you get the wrong ratio, you can justify your reasoning and still get an excellence. So for every 1 mil of acid, I need 10 mils of sodium hydroxide. Now I'm just going to jump to the excellence level stuff just to kind of explain why we need to do our dilution. I'm just grabbing a green color pen. So we have obviously our planning, all this stuff here. We have some math that we're going to do. We have a procedure that we're going to propose. And then you see at the back here, it says, on a piece of refill, please explain your proposed procedure, how your proposed procedure will improve the quality of the titration data obtained. So thinking about the accuracy and the validity of your results. Now, just as a reminder, when we talk about, trying to think, accuracy, we are talking about how close are you to the true value. And when we talk about validity, we want to talk about if you have a good method. The other thing that we want to note is that we want to make sure that our data is precise. So we want to make sure our data points are close together. AKA, you want to remove outliers. Now, have you guys talked about outliers in biology? Yes, I heard one yes. You might have heard it in stats too as well. So what is an outlier? Yeah, it's like a totally different number. So like it's a number that does not make sense with the rest of your data. The only way you're going to be able to find outliers is if you have enough data to see if something looks funky. Yeah? So that is something else we got to think about. Now, I do want to talk a little bit about this proposed procedure, just to kind of start getting you guys thinking about why we are doing this. Remember that this bit here is the excellence requirement. So if you don't do it, you're then going to be limiting yourself to either achieved or merit. The other, actually, yeah, let me just go on and start talking about that. All right, so first thing I want to think about when I'm trying to justify my procedure is why I need to dilute it. So first up in your justification, you should have, why do you need to dilute your stock? So currently, my ratio is 1 milliliter of sour cream, my acid, to 10 milliliters of my sodium hydroxide, which is at 0.1 moles per liter, and that is my base. If I was to scale this up, my smallest pipette is what size? It's about 10 mils. So if we're going to scale up for titration, smallest pipette is 10 milliliters. So I would need to use 10 milliliters of my sour cream. If I was to do this, and this is a 1 to 10 ratio, how much base would I need? Is it 10 to 10? If 1 mil of acid requires 10 mils of base, if I had 10 mils of acid, how much base would I need? 100. So if I was to do this reaction without diluting my acid, I would need 100 mils of my base. Is that going to work? No. So this won't work. Because the burette is only 50 mils. Therefore, the sour cream needs to be diluted. So I'm showing I understand the reasoning behind what I'm doing for part A and Y. Questions at this point? Keep going. Keep going? All right. So let's start planning what I need to do in order for this dilution to work. So in my planning, I need to look at the information that has been provided for me. So the first thing is I need to see what pipettes I have. So if I want to see what pipettes I have, I go back to this sheet over here. And I look over here, it tells me that you have here we go. Oh, here we go. That's what I want. Okay, so we have 10 mil pipettes and we have 25 mil pipettes. So these are my two options for pipettes. So I'm going to write that down. So I have a 10 mil pipette and I have a 25 mil pipette. Next thing I'm looking for is my flask volumes, because it's going to tell me what I can dilute things by. So if I go back to my sheet over here, I see it says 100 and it says 250, so those are my two options. Are we okay with that so far? All right. From that information, I need to plan out then what potential dilutions I can make. So some things to kind of keep in mind. You have your flask, and it's a round bottom flask like this. And it'll have a set marker, and that marker will be, for example, 100 milliliters. You will have a pipette, like the ones you guys were using the other day. And it will also have a set marker. Say, for example, 10 mils. So you will put 10 mils of your stock in there, like that, and then you will fill the rest with water. And that's going to tell us our dilution fold. So if I did 10 into 100, I would get a 10-fold dilution. So 1 into 10, 10-fold dilution. Are you okay with that as an option? All right, if I did 10 into 250, that would be a 1 in 25 dilution. So I'm just calculating out how much I'm diluting it by. So if I take 10 mils and I put it into 250, then I'm going to get 25-fold dilution. So it's 25-fold less concentrated than the original. So that is 10 into 100, 10 into 250. I could do 25 into 100. So if I did 25 into 100, what's the full dilution? If I do 100 divided by 25, I have 4. So this is a full dilution. Last option we have is 25 into 250. If I did that, what's the dilution? Yeah. So those are my 4 options. 3 of them are the same, or sorry, 2 of them are the same. So I have 3 choices. I can dilute it 4-fold, 25-fold, or 10-fold. All right, let me know when you're ready. All right, next page. Okay, so the next question then is, which dilution should I use and how much of that dilution should I use? So there's two questions here. I'm going to dilute this and then I'm going to use this in my titration, but I don't know how much of this I need in order to get a good titration. So we are going now to this page over here. So we need to figure out then how much we need to dilute it by. Let's get my... And then how much we need to take by it. Sorry, my brain's not running as fast as I should. Okay. So in order to figure out what we should be doing, there is a calculation, and that is that the titrate volume, so this is the volume out of the burette, in this case, how much base, I can figure out that volume if I take the aliquot volume this is a reminder of our vocab. That is the volume out of the pipette. So this is how much of the diluted acid. Should actually add that you don't need to write this stuff in for your assessment. This is just me helping explain what each thing is. So the aliquot volume, if I multiply that by the desired ratio divided by my actual ratio. So desired ratio is the potential dilutions we can make. And the actual ratio is what you found experimentally. All right. So the rough ratio that we found experimentally is this number over here. So that was 1 in 10. Or if you want to write it, 0.1. The potential dilutions are the ones that we calculated on, where's the page gone? Over here. So these over here are the potential. So what I do is I create a small little table. Oh, sorry. Potential, sorry, I'm going too fast, am I? All right, keep going. All right, I create a little table on the side to do my calculations. So what I put on this side here are my possible dilution factors. So my three choices were 4-fold, 10-fold, and 25-fold. So that here is my potential dilutions. The next thing I then need to include are my potential aliquots. So if you guys remember, we said that we had two options for pipettes. We had 10 and 25. So these two pipette sizes. So that is my aliquot volume. So basically what we're asking is, if I take a 4-fold dilution and I take 10 mils of it, how much will my titrate volume be? How much base will I need is the question we're asking. So the numbers that we're finding in here, that is going to be your titrate volume. All right, let's start plugging it in. Just trying to find my calculator. All right, so the first step in my calculation is I need to figure out my aliquot volume. So that's going to take that number here, 10. So I'm doing 10. And then I'm going to multiply it, and I love to use parentheses to make sure that I don't have something funny going on. So 2 brackets. The first thing that I'm multiplying it and then dividing it by. So my desired ratio, so my potential dilutions, so that's 4-fold. So 1 divided by 4, or 0.25. Then divided by my actual ratio, which is 1 in 10. Like that. Do you guys want me to write it out so you can see what I mean? Okay, so what I've just entered into my calculator Let me just try to find all my colors. All right, so I had in my calculator equal, or how I'm trying to do it. So I'm taking the number 10, which is my aliquot, and I'm multiplying it by, and then I'm doing some closed brackets, my desired ratio is 1 in 4. Or if you want, you can enter it as 0.25. That also is fine. And then I'm dividing that by my actual ratio, which is 1 in 10. And then I'm doing closed brackets there. Or you can enter that in as 0.1. So when I enter that into the calculator, 10 times open brackets, a quarter divided by a tenth, close brackets, hit enter. It says you're going to take about 25 milliliters. So if I was to take a 4-fold dilution and 10 mils of it, I would expect I would need roughly 25 milliliters of my my base for that to work. Just checking over in there. Do you guys want to see another one? The other page? Yep. So 10 milliliters of the aliquot, the 4-fold dilution. This is how much I would need for my base. So this is how much base you'll need. Let's say I wanted to change that and I wanted to do a 25 milliliter aliquot of the 4-fold. So I want to keep all of this the same. The only thing I'm swapping out is I'm changing this number to 25. So if I have this already entered in my calculator, I can reuse that entry. And I can just change that to 25. Everything else in the equation stays the same because I'm still doing the 4-fold dilution. Are we okay with that? I hit enter, and it says that now if I was to do if I was to take a 25 mil aliquot of the 4-fold dilution, I would need 62.5 milliliters of my base. And so then I add it into this guy over here. Are we good so far? Do you guys want to do the other 4 calculations, and then we can check our answers? I see a head shaking no, because Jason doesn't feel confident. Do you want me to do 1 more, and then you guys do the other 3? How about I do 1 more? You want to sleep, I know. I want to sleep too. All right. This one here, we're doing a 10-fold dilution. So when I change the number that I'm entering into the calculator, I'd be changing this number here. Instead of being 1 and 4, it'd be 1 and 10. So I do 10 times close bracket 1 and 10 divided by 1 and 10 again, because that is my actual value, close bracket. Do you want me to write that out? Okay. So if I was to do this, it would be 10 times, starting our bracket, 1 and 10. So I'm saying I'm doing a 10-fold dilution. And we're using a 10 milliliter aliquot of that. Right, and then we divide it by 1/10, because that is our actual. And then we plug it all in the calculator and see what happens. So 10 times by 1/10 divided by 1/10, it's going to be 10 mils. So if I was going to go put this into my table, a 10-fold dilution and taking 10 mils of it, I would require 10 mils of my base. All right, you guys try the other 3, and then we check our answers. I want to give you guys a break from me talking. So I'll leave these 2 things up. So do the calculation for 10-fold and 25 mil, and then 25-fold 10 mil, 75-fold 25 mil. All right, so this one here, if you did your math correctly, change this 10 to a 25, it should be 25 milliliters for that one. Hopefully you guys got that. Cool. All right, and the next one down, you're doing a 25-fold dilution, and you're taking 10 mils of that. So you should have gotten 4 mils for that one. Yep. If I change that to 25, then it is a 10. All right, questions, concerns, comments? All right, here's some of the good news of this. So the good news is that there are multiple correct answers in this. So this is something that I find a lot of students have a hard time wrapping their head around because they're so used to chemistry having right answers or wrong answers. But the thing is, there are multiple ways to do things correctly. So what I'm looking for is I want to make sure whatever proposed procedure you use, that the titrate volume falls between 10 and 25 milliliters. So for excellence, the titrate volume needs to fall between 10 to 25 milliliters. For merit, for some reason, if you do something wonky and you grab a weird number, the range for merit is 8 to 30 milliliters. So just keep that in mind. So when I'm looking for these numbers, I'm asking myself, are they between that range that I need? So 25 milliliters, does that fall within my range? Yes, so I can use this method. This method over here that says 62.5, will that get you an excellence? No, it's too big. Will it even get you a merit? No, it's still too big. So that one would result in you just getting an achieved. This one over here falls between 20 and 25, 10 and 25. So that one can get you up to excellence. This one here falls between 10 and 25. That one can get you up to excellence. This one here, does it fall between 10 and 25? No. Does it even fall between 8 and 30? No. So if you use this number, you are going to get an achieved. This one over here, 10 to 25, that one's fine. Okay? So whatever method you select, it needs to fall within that range. Okay? Any of these ones with a tick mark are correct. So it's up to you which one you want to use. Doesn't matter to me, so long as the method is correctly pulled across here. So I said from that table that was created, circle the possible tie tray that you think is acceptable. If you have more than one acceptable answer, pick one to fill in the proposed procedure template. So just pick any of these to use. So I'm going to pick the 10-fold dilution with a 10 ml pipette. So that's the one I'm going to use. If you chose a different one that has a tick, that is fine. All right, let's now fill in the proposed procedure. So the original solution of household sour cream needs to be diluted, and I'm diluting it 10-fold. That's how the information is getting there. And a size of the sample will be of this diluted solution will be used. So I am using the 10 ml. So you see how I'm grabbing those two numbers? 10-fold dilution, 10 ml aliquot. All right. This required dilution can be achieved by pipetting, and then I have to explain how do I want to make that solution. So we go back to our previous paper, and we're explaining how we did the dilution. So I have two ways to make a 10-fold dilution. I can do 10 into 100, or I can do 25 into 250. Is it lost? There we go. So do you see how I have two that work for the 10-fold? Let me grab a different color. So this one's 10-fold and this one's 10-fold. Is there a preference to which one I use? No. Whatever one you use, just make sure you justify it. I personally would go with this one because it makes more solution. Okay? So I need to explain then how do I dilute it. So for the required dilution, by achieving this, I would pipette 25 milliliters of the original solution, and I would add distilled water to make it up to the mark of a 250 milliliter volumetric flask. That makes a 10-fold dilution, doesn't it? All right. In the actual titration with the sodium hydroxide, I will use 10 mils to deliver the aliquot, just to kind of show you guys this number and this number should match, because we're talking about what we're taking for our aliquot. To deliver 10 ml pipette to deliver the aliquot of the diluted household sour cream into a titration flask. I will add a few drops of the indicator and the titrate against the standardized sodium hydroxide until the color change is from colorless to pink. I would predict the average titrate volume to be approximately, and then I'm grabbing it from this table here. So 10 mils. And I'll just grab the colors. So that is coming from the table. Just going to try to color code it. This is coming from the aliquot volume, and then this is coming from the full dilution from there. Does it disappeared again? Sorry, I know I'm talking a lot. Cool. All right, so just so you guys are aware, filling in this proposed procedure and doing those calculations, that gets you up to a merit, which is why I put it into blue. If you make a mistake in this proposed procedure, and usually the mistake is here with explaining the dilution, you will go from a merit to an achieved. And then the excellence is explaining your proposed procedure. Do you guys want me to do the excellence today, or do you want me to hold off? I hear some hold off. All right, that's fine, I don't mind. Okay. Let me show you guys where the work is. Let me unzoom this in. Reset. There you go. Okay. So what I have done is I have created some extra Part A practice questions. Hopefully this will load it. I haven't printed it out because, you know, budget costs, but it's the same format as what we've done with that yellow piece of paper. In this example, I've given you the ratio. So I've said you have 1 ml of acid, and for 1 ml of acid, you need 8 mL of base. I've given you the pipette sizes and the flask sizes, so you can figure out the potential dilutions that you can do. And then you make your table, like I did, and then you fill in the proposed procedure. So that's our practice, and then this is the next practice question. So I just did different variations of that same question. All I've done is I've changed the numbers. So I've changed the numbers here, and I've changed the numbers here. So that's going to be practice work, and then I can talk about how to do the write-up for the excellence on Monday. Sound good? So just to kind of give you guys a reminder, tomorrow you guys have Ms. Falasolo. I would expect you guys to be working on these practice questions tomorrow with her. I'll leave my notes for her, but I'm not really sure how much she's going to understand how to do these calculations. So we'll try to put the recording up tonight so that way you guys can use that as reference. Okay? And then on Monday, I will talk about how to get up to the excellence level. Cool? Alrighty. You can start doing some practice now.